Today, I am going to show you the unit circle. So we've got all this going on here. I'm going to do my best to explain it, what each piece represents, and how we're going to use it. There's a lot of information, and I don't want this video to be excessively long, so I'm going to do my best to explain what's going on right now, okay? So what's happening is we're actually just looking at a bunch of our special right triangles, our 45, 45, 90s, and our 30, 60, 90s. So we can see here our 30, 60, 120, our 30-degree rotations, and I wrote this one wrong. This is a 45-degree angle here. So then we have our 45, 90, 135, 180. We talked about these in terms of pi already, so what I'm going to do is I'm going to show you our angles of rotation with radians. So we know at 0 degrees, we're going to be at 0 radians. 30 degrees, that's a pi over 6 radians because there are 30 rotations in 100 degrees. 180, not 100. Okay, 45 degrees, this is going to be a pi over 4 because there are 4 of those in 180. And we got pi over 3 for 60 because there are 3 of them in 180. 90 degrees, this is going to be a pi over 2. So what we're seeing is those types of angles. And the cool thing is with the unit circle is this first quadrant is just going to be reflected in the other quadrants, and it's going to change our sine and cosine values. So we're going to keep rotating here. If I go with my pi over 4, there's 1, 2, which is going to reduce, 3. So here's 3 pi over 4, and 4 pi, which is just 180 degrees. So we have 1, 2, 3, 4. So here we're going to have 5 pi over 4, 6 pi over 4, which is going to reduce to 3 pi over 2, and then 7 pi over 4 at 315. One more, we're going to have 8 pi over 4, which just reduces to 2 pi. And we already know that 180 degrees equals pi, and 2 pi equals 360. Okay. So now I'm going to rotate my 60 degrees. So 60 is going to go to 120, so that's 1/3. Now I'm at 2/3. And then I rotate to 3/3. 4/3. 5/3. And 6/3, which is 2 pi. Okay? And our pi over 6s. So we have 1, 2, 3, 4, 5. Everything else reduced. 6, 7, 8, 9, 10, 11, and 12. So what we're seeing here is our angle of rotations. But the cool thing is we know those reference angles. So we know a 2 pi over 3 is equivalent to a reference angle of 60 degrees, or pi over 3 radians. So we're going to use that to help us out. All right. So because this is called the unit circle, that's because our radius here from the origin to our circle is 1 unit. So our radius is 1 unit long. So here, this point is at 1, 0. This point is at 0, 1, -1, 0, and 0, -1. So those are the points. And so now we're going to take that point and we're going to rotate around the unit circle. I'm going to go ahead and use, I'm still using green, sorry. Okay, if we rotate up to our 30 degrees, we're creating this right triangle. And with the right triangle, my radius is 1. So I need to know how far to the right I went and how far up. So I need those x and y values. So we're going to use this special right triangle. I'll go ahead and flip it on its side so we're looking at it more, wrong side, as a 30-degree angle. So it's actually going to, oh, I did it again, look like this. So if this is 30, this side was 1, 2, and √3. But because we have to change it, so our hypotenuse, our radius is 1, I'm going to come in and I'm going to divide everything by 2. So now I can see that my radius is 1, my y value here is 1/2, and my x value is √3/2. So that's the position of that point. Okay? That's going to hold true here at our 5π/6 where our reference angle is the same, but now we went left, so it's a negative √3/2 and a positive 1/2. That's true for every reference angle of π/6. So that's true here. We went left, √3/2, and then we went down, 1/2. Here, we went right √3/2 and down 1/2. Okay. The 60-degree reference angle is very similar, but now the x is the short side and y is the long side. So we're going to flip that point. Now we're at 1/2 √3/2. Negative 1/2 √3/2. Negative 1/2 negative √3/2. And positive 1/2 negative √3/2. So again, we're just describing the position of that point on the outside of our circle. So our last set of points here, we're going to talk about our 45, 45, 90. So our x and y is going to change because we need that hypotenuse to be 1. So again, we divide everything by 2. So when we look at the triangle here, our base and height are going to be the same, √2/2. And then we rotate. So here we went left, √2/2, up, √2/2. Left, √2/2, right, √2/2. And here we have a positive √2/2 and a negative √2/2. So here we have the unit circle, and this is how it's set up. All I want you to have memorized and to focus on is this first quadrant, because everything else is just a repeat. From there, we need to remember the facts. I'm just going to give me some talking space here in the middle. All students take calculus. All of our trig functions are positive in the first quadrant, sine in the second, tangent in the third, and cosine in the fourth. Okay? So now that we have that built, hopefully this makes sense. We're going to come back and use it a little bit more in the second video. It's just I don't want to take too much time for this first intro. Okay, good luck.